Okay, this problem is from Module 6, solving a system that is inconsistent or consistent dependent. Two systems of equations are given below. For each system, choose the best description of its solution. If applicable, give the solution. So first up, we have x plus 3y equals 9 and negative x minus 3y equals negative 9. The second system is negative x minus 2y equals 8 and x plus 2y equals positive 8. And our choices are here. The system has no solution. The system has a unique solution. The system has infinitely many solutions, and they must satisfy the following equation. So first thing we'll do here is combine the two equations. Negative x and negative x, they become 0. 3y and negative 3y, they also become 0. So we have 0 on the left side of the equation. On the right side of the equation, 9 minus 9 is 0. If you get that the left side is equal to the right side, then what you have are infinitely many solutions. Now, if you have infinitely many solutions, you have to come up with the equation that they must satisfy. So let's erase this here so we can once again see the equations. And what we'll do is solve one of the equations for y. So let's take the first one, x plus 3y equals 9. Solve that for y. First thing we want to do is move the x to the other side. And what we'll wind up with is 3y equals negative x plus 9. The next thing we'd like to do is divide both sides of the equation by 3. The 3's, of course, will cancel out, which will leave us with the positive y that we already have written. This 3, remember that it divides the negative x and the positive 9. So negative x divided by 3 is going to get us, you can write negative x over 3, and in a minute I'll show you another way to write it. And 9 divided by 3 is simply positive 3. So this would be an acceptable answer. Alternatively, you can write the negative x over 3 really means negative 1/3 x, and you can put negative 1/3 x plus 3. So either of these two would be acceptable. Okay, let's get to the second one. We have negative x minus 2y equals 8 and x plus 2y equals positive 8. This looks a lot like the first set, but let's see what happens when we combine the equations this time. Negative x and positive x, 0. Negative 2y and positive 2y, 0. Now, this time, 8 plus 8, this is 16. 0 is not equal to 16. Therefore, since the left side of the equation is not equal to the right side, the system has no solution, and we would have to pick choice 1. So the first set of equations, the system has infinitely many solutions, and they must satisfy the following equation. You can either write it as y equals negative x over 3 plus 3, or y equals negative 1/3 x plus 3. And the second system of equations has no solution.